Hello and welcome to this video in the series Python for Beginners. Now we will move on in this video to look a little bit at the software development process, and then we will implement a simple program to illustrate this process. Now, as you saw in the previous video, it is easy to run programs that have already been written. The difficult part comes in when we actually have to come up with programs on our own to solve problems that we encounter or that are given to us. What we need to remember is that computers are very literal and they must be told exactly what to do right down to the last detail. Writing large programs is therefore a daunting challenge. Therefore, we need a systematic approach. So, the process of creating a program is often broken down into neat steps that we can follow. So, in a nutshell, here is what we can do. Firstly, we need to analyze the problem. This means we need to figure out exactly what the problem to be solved is. We need to understand a lot about our problem until we know exactly what the problem is. Because without understanding what the problem is, we cannot write our program. Then we need to determine the specifications. This means we must be able to describe exactly what our program will do. At this stage, it is not important for us to worry about how the program will work, but rather we should decide exactly what it will accomplish. Then we need to create a design. This is where we formulate the overall structure of the program. This is the how of the program. The main task is to design the algorithm that will meet the specification. Now, what is this word I just mentioned, algorithm? Well, simply put, an algorithm is a step-by-step solution to a problem. Another way to think of it is as a recipe that we need to follow. Then we need to implement the design. This means we translate the design that we created previously into a computer language and then type it into a computer. In our case, we will be using the Python language to implement the algorithm that we came up with. Then we need to test and debug the program. We need to run the program and try it out with various inputs and see whether the output works as expected. If there are any errors, which are often called bugs, then we should go back and fix them in the code. This process of locating and fixing errors is called debugging. And during the debugging phase, our goal is to find errors and to think of everything that might break the program. And finally, we need to maintain the program. We need to continue developing the program in response to the needs of the end users. Most programs in the world today are never really finished. They keep on expanding and changing over time due to the changing needs of the users. So now that we have gone over some theory, let us put that into practice by looking at an example program. We will be doing a temperature converting program to help Susan solve her problem. So let's jump right into that. Now, Susan is a computer science student spending a year of studies in Germany. She has no problems with the German language, but her one big problem is that she has a hard time finding out what to wear in the morning because the temperature she hears on the radio comes through to her in Celsius, whereas she is used to hearing it in Fahrenheit. So, What can Susan do to solve the problem that she faces? Well, she thinks about writing a computer program. And being a computer science student, she goes through this software development process in order to design a solution and implement her design. So let's see how we can go through the steps of the software development process and help Susan solve her problem. So, we want to write a temperature converter program, but there's a problem, and the problem is that temperature is given in Celsius, but Susan is used to Fahrenheit. So we need to determine specifications for our program now that we know what the problem is. We need to get input in Celsius and convert it to Fahrenheit. But now what is the equation to convert Celsius to Fahrenheit? Well, in today's world, we can Google it. So let's jump over to Google and have a look what it says when we say converting from Celsius to Fahrenheit. And we see that it says to convert temperatures in degrees Celsius to Fahrenheit, multiply by 9/5 and add 32. So what that means for us is Fahrenheit is equal to 9 divided by 5 multiplied by Celsius, and then we add 32. Okay, that seems about right. Then we need to create a design for our problem. So what is a design? Well, a design is where we will use a specific algorithm. This case is going to have input, where the user is going to input what is the temperature in Celsius. There's going to be some processing, which we already handled here above with this equation. And then we need to display some output for the user. So what is our next step? Our next step is to make sure that we can write this in pseudocode. So pseudocode is plain English or human language that is very detailed but is not computer code. Once we can write in pseudocode, we can much more easily implement that into computer code. So here's an example of a solution to this problem in pseudocode. Input the temperature in Celsius, calculate Fahrenheit equals 9 divided by 5 multiplied by the Celsius temperature plus 32, and then we output Fahrenheit. Then we need to implement the design. So here comes the interesting bit. Time to write some code. So we need to jump over to idle and make sure we create a new file, and let's start. So we need to remember it's always good practice to start off with some comments, such as what the program is supposed to do. So, program to convert Celsius to Fahrenheit. Let's just capitalize that. Okay. Seems like we have a good start so far. So let's implement our pseudocode in a function called main, like we've had before in the previous video, the chaos.py file. We had our code in a function called main. So we'll go through functions in a much later video in depth so that we understand what they're all about and writing our own functions. But for now, let's write this. And then our code will come in this block indented over here. So what we had was, we need to get the input for Celsius. So how do we get input? Well, we'll call our variable Celsius. We'll get the value of eval input, and then we're going to ask the user, what is the Celsius temperature? Okay. Now what is our next step? Remember, input, processing, output. So now we need to do some processing. And our step was to say we need to get what Fahrenheit is. So we can call this variable Fahrenheit. We'll get the value of 9 divided by 5 multiplied by Celsius plus 32. That's the equation we found on our friend Google. And then finally, for the output, we will use the print function, and we will write a string such as the temperature is, and then we close that quote. Now here we see various arguments that we can put into the print function. Now if we put the normal separator here, we see is a open space, open white space over there. So if I put a comma in there and I put any other variable or another string in here, it's going to give a white space and then that string or variable. So let's say the temperature is, and then I'll put my Fahrenheit variable in there. Let's just neaten that up. It's just, oh, it's some typo over here. Fahrenheit. And then degrees Fahrenheit. Full stop. Okay, so let's just make sense of this print function again over here. The output is going to be the temperature is, and there will be a white space. Not because of this. I'm just putting a white space there for clarity's sake. But that's just how the print function works when we have different arguments. This is an argument, one argument. Then if it's separated by a comma, like that, this is another argument, and then this is another argument. Note also, if I had the comma inside the quote mark, this would have still been considered as one argument. Okay, but we'll explain that in later videos. Don't worry about it for now. Okay, and then to make sure that our function can run, we need to call the main function over there. Then we can save that, and let's call it convert. Okay, we can run that, and if there are any errors, we need to remember step 5 in our software development process, which is testing and debugging. So let's see if we need to test and debug. What is the Celsius temperature? Okay, so now we can think of, if it is 0 degrees Celsius, then it should be 32 degrees Fahrenheit. So if Celsius is 0, okay. Now look at this. We're getting an error, which is a name error. It says name Fahrenheit is not defined. And it gives us a suggestion, did you mean Fahrenheit? So there was a spelling error over there. So what we need to do is, we close the shell, we see where our error is here, Fahrenheit, right? So we've done some debugging of the error, and we run our program again. Let's try with 0, and we get the answer. The temperature is 32 degrees Fahrenheit. Let's try running main again with another input. What is the Celsius temperature? Let's try 100 degrees, boiling point. Temperature is 212 degrees Fahrenheit. So the program seems to be working fine with those two inputs. You may go ahead and try running the program with different inputs, and maybe type in on Google and see what the temperature should be according to Google, and see if this program works as expected. So what we're going to do now is, we're going to go over to a little bit of exercise for you. And I'm going to bring it over here. So what I want you to do is, write a program that converts temperatures from Fahrenheit to Celsius. So this is the other way around. Okay. So you're welcome to pause the video here and try it out. And then if you're stuck, continue watching and see the solution. Okay. So we need to write a program that converts temperatures from Fahrenheit to Celsius. So what do we need to do? Well, I'm going to write a new program and keep this one as convert.py. And I'll simply copy the code, okay, and I'll create a new file, paste that in, and I'm going to change some things around. For example, Fahrenheit, put it in there, and then we swap these around. What is the Fahrenheit temperature? So instead of writing from scratch, I'm merely using what we already have, but I need to make sure that I put all the names in the right places again. So let's put Celsius in here. Let's put Celsius in here too. Okay, so all the names is correct. The only thing I need to change is now the equation. So we again have our friend Google that we can use. And the equation from Celsius is Celsius equals 5 divided by 9 multiplied by Fahrenheit minus 32. Okay, so that's what we need to do this time. So let's go into our code, and this time it's 5 divided by 9 multiplied by Fahrenheit and minus 32. Okay, so I'm just having one glance over everything to make sure that it's good to go. And we should remember, if it doesn't work as expected, we should do some debugging. So I'll call this convert 2. Okay, let's hit F5. What is the Fahrenheit temperature? Let's try 32. Temperature is negative 14 degrees Celsius. So that's a bug. And that bug has to do with the equation. We did not read the equation properly. If we see the formula here, mathematically, the Fahrenheit minus 32 is in brackets. That needs to be computed first before you multiply over here. Okay, it's not merely all in the same order. Remember, BODMAS, order of operations. Fahrenheit minus 32 needs to be computed first before this multiply by 5 over 9. So let's go and fix that up in our program. And all we need to do is put parentheses around over there. And now, after having tested and debugged our program, we press F5 and see if it works this time. What is the Fahrenheit temperature? Let's try 32, and it works as expected. We get a temperature of 0 degrees Celsius. And if we run that again and put Fahrenheit as 212, we get our temperature of 100 degrees Celsius. So, thank you for watching this video, and in the next one, we will look at elements of Python programs, such as naming conventions and expressions. See you in the next one.